Hello, fellow Geminians. Good evening. Well, welcome to this bootcamp. We thank God that He has given us this opportunity to learn a skill. I take this opportunity to thank the executives of CHISA for organizing this experience bootcamp so that we can learn a skill in addition to the theories and everything that we are learning in the classroom. I pray that may God help us to get whatever we need in Jesus' name. Amen. So the courses being taught is MATLAB, Python, Excel, and Aspen. So I will be taking you through Aspen. My name is Obimenu Clinton, and we are going to begin soon. And in this course, we are going to go through the following outline. So the day one, as in today, 4th, will be an introduction and general overview of Aspen Plus. I know after this you will be abreast with Aspen and you will know Aspen Plus a bit so that we can move. And the day two will be fluid handling equipment, where we are going to learn how we can use the knowledge in Aspen to model pump, a compressor, pipe and pipelines and valves. Or in day three, we are going to deal with heat exchanger equipment. Thus, we are going to deal with a shortcut heat exchanger equipment, and we are going to look at a rigorous or a detailed design heat exchanger. And the day four, we are going to talk about chemical reactors. As we know, we cannot do anything in chemical engineering without a reactor. Yes, where are we going to get our products from? Yes, so we are going to learn how we can use our spin to model chemical reactors on a stoichiometric base, an equilibrium base, and a kinetic base. And the day five will be a separation processes. That we are going to talk about flashes, flash columns. We are going to talk about decanters. We are going to talk about normal separator. We are going to talk about distillation column. And in this, we are going to use shortcut models and also detailed models, which is rigorous models. And the day six, after we have gone through these 5 days successfully, we are going to take a plant-wide simulation and do it. And the day seven will also be a plant-wide, and we bring the boot camp session to a close. So admonish all of us that in the next 7 days and next 7 scheduled days that will be designed by us, I want us to um, bring our focus to this so that at the end we all are going to get something from it. Thank you for joining, and we begin soon. So we have to talk about Aspen Plus. Aspen Plus. It is manageable to solve a model structure of a chemical process which has small number of equations. If you are going to solve um, a chemical process calculation around a mixer, heat exchanger, distillation column, just one, it is easier to do that. But however, if you are supposed to solve a problem, the same problem in a plant. For example, those who are in final year, you have designed a plant and you are supposed to solve them. If you are going by hand, yeah, you can do it, but it will be a bit challenging, and because you have many units, many streams, recycle streams. So in view of this, we make use of process design softwares such as we can use a ChemSep, we can use a ChemCAD, Unisim, we can use Excel, we can use GPROMs and many others. And we can use Aspen as well. So most widely used commercial process softwares is the Aspen because it has large data bank, experimental data bank for thermodynamic and physical parameters. So we are going to learn Aspen because it is mostly used and it's a commercial tool. So once you know how to use it and you find yourself in any company that will be using Aspen, then you are true to go, you can move. You can move. And how did this Aspen came about? During the 1970s, researchers developed a novel technology at MIT. We all know Massachusetts Institute of Technology in the US. So they developed a novel technology with a US Department of Energy funding. This was funded by US Energy Department of Energy. So the undertaking project that was being funded by DOE, that's Department of Energy in the US, it was targeting what we are going to learn in this bootcamp, which is the Aspen. So the topic for their project, the funded project, was Advanced System for Process Engineering. Advanced System for Process Engineering. So the Aspen that we are going to talk about was somebody's project, some kind of people project who were engineers like us, their project. So advanced system for process engineering is what we are going to talk about. So we are going to learn something. That was somebody's project, and it was originally made just to be able to solve nonlinear simulation problems. Yes. So that was why it was being made. That was why it was being made. And in 1981, a publicly traded company, which is Aspen Tech, founded a commercialized simulation software package. So this tool was being sold or it was being commercialized by this Aspen Tech. But you have to know that this was being designed by people in MIT. Sorry, MIT. So publicly used and publicly launched, Aspen Plus came into being for people to purchase it in 1994, and from then it has gained trust from many companies in using it to predict future happenings in their plants. So there's a little bit of um, history or introduction about what we are going to learn. So it was designed by some class of um, researchers, as many of us are researchers. This was designed by somebody. So your scope, I want you to open your scope so that we can understand it very well. All right. Thank you. And by the end of this course, as I have shown you in the outline for this bootcamp, Aspen bootcamp, you are supposed to be familiarize yourself with the software, and you are supposed to be able to simulate simple simulation problems, and you are supposed to do a project, because after this a certificate will be issued that you know how to use Aspen bit. So maybe you have moved from a beginner level, as we are, most of us are beginning, and to an intermediate user of the software. So admonish that you put in your all so that we can get to that session. And for today, just as I have introduced the course to you, we are going to do some small introduction as I have introduced, and we are going to learn Aspen Plus. So as I was talking, I only mentioned Aspen, but Aspen have a lot of packages. Let me try and find them. So I want to show you, if you come to your and you search for Aspen, the package that has been installed here, Aspen, sorry, uh, okay, so if you search for Aspen, you are going to see that we have different kinds of Aspen that we are seeing here. So you will see that the Aspen, we have Aspen HYSYS, we have the Plus that I normally use, and we have Aspen Energy Exchanger Design, we have Aspen Energy Analyzer, which will be used later by you, or we'll do it here. We have Aspen customized properties. We have database. So but for this, also we are going to take into consideration Aspen Plus. We are going to focus on Aspen Plus, which was um, the main software that was designed by the MIT people. Aspen Hysis was bought later by the company, and they named it Aspen Hysis. It was at first Aspen Hysis Corporation, and later on, because Aspen Tech bought it, they name it Aspen Hysis. So we are going to concentrate on Aspen Plus. And after this, you will be able to know how to input chemical components. You'll be able to know how to input property method and perform a simple simulation. Okay. So let me throw a little light on the chemical process. It will be thrown on the next slide. So this will be the reference book that we are going to use. Yeah. So you can check them out, and I will send it by the end of this boot camp. I will send it to you. Yes, my favorite, the one that I have used is Learn Aspen in 24 hours, and that of Professor Kamal's book, and a bit of Rodriguez's book. So what is Aspen? As I've already explain it to you. It is a flow sheeting simulation tool. You know, Aspen works on a principle of flow sheet. So before it can do your work for you, you have to get your flow sheet intact. What do I mean by flow sheet? It was in first year. So a flow sheet is just like something that is flowing. For example, uh, you have your okay, let me calm down. You have you have a tank, and there is a pipeline that has been connected to it, and the pipeline, what is going in and what is coming out, that will form a flow diagram for you. So it's a flow sheet into it, works on the principle of flow sheet, and it model quantitatively model a chemical processing plant, or a process. So you can use it for batch processes or a continuous process, and it's a steady state too. Okay. So I term the use of Aspen, how it is used, and the main usage is that it is used to mimic the actual process. So you will see that there is a petroleum corporation, for example, TOR or GMPC, their plant, and you will be in your room, you'll be in KNUST, and you will be mimicking what is going on there, be mimicking what is happening in pumps, what is happening in pipes, so that you can tell them, oh, if you try to increase the flow to this part, there will be cavitation in the pump. There will be cavitation in the pump or along the pipeline, so you can do. So there is a powerful tool. Yes, it's a prophetic tool in chemical engineering. You can use it to predict what will happen in future, and you can use it to verify what is happening. So it is a tool that we are going to use to mimic actual process. Yes, so we are going to use it to produce a similitude resource of actual processes. Okay. So how does this work? So in order for you to be able to use it well, you have to provide a chemical component for the software. So you are not going to give the software the chemical composition database. It is already embedded in Aspen. It has a large database, but you are supposed to provide it with a chemical component that will be present within your simulation. So for example, you want to mimic the production of singers singers in a company. So the chemical component that will be produced is you are supposed to provide the composition singers, for example, CO, carbon monoxide, and hydrogen gas. And you are supposed to provide what is going to react to give you that product, which may be you are doing steam methane reforming to produce the syngas. So that means you need to provide methane you have to specify methane, and you have to specify water. So at the end of this course lecture, you are going to know how to specify chemical components. Yes, so any chemical component that will be present within your plant, the plant that you want to mimic or the process you want to mimic, that needs to be specified. So when you are done with that, you have to specify the thermodynamic model. Aspen contains almost all the mathematical models in chemical engineering. The mathematical models in chemical engineering, the Maxwell's relation, Fensky equation, Arrhenius equation, all of them have been embedded in Aspen. And the thermodynamic model is a model that contains these specific formulas. For example, if you want Aspen to work your process, to solve your process in an ideal manner, then you can choose an ideal property method. So at the end of this, you will know how to select a chemical property. Aspen has designed a method assistant that can help you to choose a property method that will make you move. So that's a property method. So I'll show you how you can do that. By the end of the it, you get know how to use it. All right. So after that, you have to provide your flow sheet, as I have already explained, and you have to give your process conditions. So process condition, that's the thermodynamic conditions, the material stream conditions, and everything. So if you are saying you want to heat water, so you have water in your stream, so you have to provide how what is the water is H2O. You have to specify that. You have to give a process condition to it. Uh how hot is your water? What's the temperature? Or how cold is it? What's your temperature? What is the pressure? What is the flow rate of the water that you say is coming in? So you have to provide that. And if you are using a mixer, is there a pressure drop within the mixer? At what pressure is a tank existing? So you have to show all of them. That will be the process condition. It's not something difficult. Aspen is a user friendly, it has a user friendly interface that's going to help us to move or get set as we move on. And I know that by the end of this, you'll be able to use Aspen, be able to use Aspen go to use Aspen. And let's move on to the next one. So areas of application, I just picked this from the Aspen interface. So you can apply Aspen in air separation, chemical processes, gas processing. For example, you want to sweet a gas, you want to dehydrate a gas, natural gas or something, you can use them. And you can use it in metallurgy, you can use it in pharmaceuticals, you can use it in polymers. Maybe you are thinking chemical engineering pharmaceuticals, yes, it's possible. You can mimic a mixing approach or a reaction, a reactor within an aspirin. For example, maybe you want to just mix paracetamol or aspirin with water. You want to produce an dilute solution of that. You can specify it in Aspen, and Aspen can give you the results. Solids, refinery, and there is a user part that you can use to model a lot of things. So it is limited, but it is not limited, so you can use it. So the Aspen that we are going to use can be used, as I have already explained. It can be used to conduct what if test, can be used to perform sensitivity analysis and run optimization investigation problems. All right. So I also tell me that with Aspen Plus Process Simulator, we can design better plants and increase profitability in existing plants. But since we are going to use it for optimization, we are going to optimize for maybe a minimized cost or a maximized profit, and it is going to help us. Yes, and because of its ability to give what will happen in the future, it is useful in R&D R&D department in companies, and it can be used for life cycle analysis as well. So people, let's get ready as we learn this powerful uh, prognostication tool And how do we use Aspen? So in these 6 steps that I'm going to explain, you can simulate Aspen. So the first one is for you to specify chemical components, as I have explained chemical components. And the next one is to specify the thermodynamic model, which is the property method. And the next one is to provide or define the process flow sheet process flow sheet. And the next one is to specify the component flow rates and the thermodynamic conditions. And the next thing is to specify the operating conditions for the unit model. That's the blocks, the reactors, the mixers, the distillation columns that we are going to use. When you are done with all these things, what you have to do is to run your simulation, view your results, and compare. Compare it to actual work. So the reason why I'm stressing on compare is that Aspen has a larger database. You can use it to run something that will not make sense uh, in real life. So you have to compare the results. Remember, Aspen is just like any simulation tool or software, is a GIGO. It works on the principle of GIGO. You garbage whatever in, it will garbage it out for you. So let us bring our thermodynamic or chemical engineering background here so that we can do proper simulation. Are you ready to simulate now? Or if you are ready, let's start. So in view to be able to demonstrate how the objectives for today, we are going to use this problem. So I will explain this problem, then we will move to the software, and we will use the software to explain this problem and solve this problem. And at the end, you get some assignment to perform. Yeah, that's very simple. So it is desired to dilute a pure NaOH solution in a chemical plant, giving 500 kilogram per hour pure sodium hydroxide and 350 pure water. What is the mole purity of sodium hydroxide in the aqueous solution? So people, this is our problem. We have now this thing you can do it in the PD lab, but we are going to use Aspen too, which Professor Kamal described Aspen as a dry lab. You are not having anything. You are just in your lab. You are just in your room and you are performing laboratory experiments. Performing laboratory experiment. That's the dry lab. Yes. So people, let's move on to um, the software and let's move. So as you open Aspen for the first time, this is the interface that you are going to see. And if you haven't done any work on it, you will see that we have recent models. The recent models, this part will be empty and all these will be available. So we are going to use Aspen Plus. Yes. So Aspen updates environment. So let me try and show you this example part cage is in this part there is already existing templates that Aspen have done, some work that has been done by Aspen. So if we go to energy session, we can see that there is carbon hydrogen reaction that has been done, and this crude distillation unit that has been done here. So we can open it to see the work that has been done. But we don't want to go there. I just show you that there are existing backup files that you can go on it and use it. So this has been to first use it, what we have to do, let's create a new simulation. So when you create a new simulation like this window will open, and in this new interface that has opened, yes, this has already been explained to show you the template that you are supposed to use. So if I choose chemical engineering template and I select this metric unit, it will provide me with this information. So in this preview, the unit that are going to be in my simulation will be this. This is degrees Celsius, bar, kilogram per hour, kilomole per hour, gigacal per hour, meter cube per hour. this will be the unit, and it has already chosen a property method for me. And the flow basis is mole, and the report composition is mole. So because we don't want already existing, because this is the first lecture, I'll go for a blank simulation, so that we that have no preview. So we are going to set everything up so that you know how to select property method and other stuff. So people select blank simulation and click select blank simulation and click on create. Sorry, create. So as you create, you wait as the tool opens. Right, sometimes this happens because you're using a crack file. Sometimes it happens like that to us. So create blank. Okay, so I am going to use Aspen version 10. Um, version 10, and I understand some of you have Aspen version 11. Yes. So as it opens like this, you come to this interface. So in this interface, you have the title bar displaying the title, that how the title of your simulation. Yes, how we are going to save it is going to change this. Okay. So then we have this environment. So this environment is called property environment, properties environment. So this is the bedrock of the simulation. This is where we are going to define our chemical components. This is where we are going to define our thermodynamic models. Then after that, we switch to the simulation environment, where we are going to see all the models, or the models palette, which contains the maybe which contains uh sorry which contains mixers and all other stuff that will be used, pressure changes, manipulators, and a lot of things. So before we start everything, I'll show you how you can specify chemical components. So let me add, this part is called navigation pane. Yeah, my navigation, which is movement. Or you can use this to move. If you want to go to property method, you just select it. Yes. If you want to go to composite components, you come to chemical components. So in order to specify the chemical components in this simulation that we are doing the problem, our chemical components are sodium hydroxide and water that we are mixing. So the first and the simplest way to specify a chemical component is to use the find option. So when you come to find option, see, the Aspen will guide you that you have set criteria and you have a name or alias. So just the alias is the chemical formula, and the name is the IUPAC name, or a name, any name that you think you can use to find the component. And we have this search criteria: begins with, contains, equals. People, begins with, contains, equals is has the same meaning as it is in English language. Yes. So begins with, that means anything that we are going to type here begins. The component that we need will begin. So if we begin with maybe water, water. So water, and we check in begins with. When we click on find now, it is going to provide anything that begins with water. So you can see that these are the compound names. We have water, we have sodium silicate, we have deuterium oxide, we have hydrogen peroxide. But when you come to the alternate name, we have water heavy. Aspen know it to be water heavy, know it to be water glass, water vapor, and a lot of things. So we have to use these search criteria to narrow our way. If we say we need water only, so the water that everybody knows, it will just narrow our way and narrow our search, the same as contains. So within 7 seconds, 8 matches has been found for water alone when we choose begins with. So I'm going to check in equals and let's find it. Okay, so now you can see that the alternate name that has been for water is dihydrogen oxide, and the molecular weight is what we are looking for, the boiling point, the Cass number, and the compound class. Compound class. So if you search by this is what we need. So once you have been able to find what you need, you just select it like this. Then you click on selected compounds, add selected compounds. So now it has been added. So you can see that it has been added here. Has been added here. That's one way that you can use to specify chemical components. So this is the alias chemical formula, the compound name, water, then this type. So the type, which is conventional, conventional means the normal state that we know the component that you have specified is. So if I choose oxygen, it will come conventional, and we know conventionally oxygen is a gas. Normally, oxygen is a gas. So if water that we have chosen, normally we know that water is a liquid, so it will be shown as a liquid phase. Okay. So now we are going to type NaOH. You can also find it with the component name. Can type it here. Can type here. Component ID here. Or we want to use chemical formulas to also find it. So you can just start to type NaOH. You hit on enter. You see that sodium hydroxide is here. Now, no ID was given, so we have to give it an component identification name. So the ID is component identification. So how do you want to identify the NaOH? Me, I'll call it base. Base. You can call it any name that you want. So maybe, unfortunately, you can also use this one to find, maybe let's find methane, CH4, and you see that CH4 has given us what we need. But because methane is not part, I'm going to use this opportunity to show you how you can delete uh, a specified chemical component which you don't need. So you just click on highlight this, select here and highlight it, and this one, and hit on delete button. So delete, and it will ask you, do you want to delete the rows? Yes, I want to delete it. And now you can see that it has come. So now the next thing from our 6 steps that we can use is to move to property method. So let's move to property method, and I can go here directly to find property method once I know, or you can see a half red circle there. So in Aspen Plus, when you see a half red circle, then you know that the required input that you are supposed to specify, it has not been fully specified, so it will be red. But whenever you see that the sky is blue, it has ticked blue, then it means that it has been fully specified, then you can move on. So we are going to see how we are going to find the property method. So now, if you don't know where to go next, Aspen has a nice assistant that is going to help you. So you are going to use the next two. It will send you to the next needing inputs. Yes, as the description here, go to the next input sheet needing input, or show what is needed to complete the current sheet. So you click on next, it will take you to what you need to do. Now it has taken us to a new sheet, that's method specification. That's the thermodynamic model, thermodynamic method. Yes, now that I didn't give anything, we don't know what we are supposed to choose. So we can ask Aspen, the method assistant, that help us. So when you come to method assistant, you click on it, it will open to the window help window. Yes, and it will ask you a few questions, then you answer. So it will ask you, we want to help you, but start by answering one of the following questions so that we can move. So you see that, say we can select the component type or process type. All right. So okay. So what do I select? Okay. So let's select component type. And because our work is chemical system, we select the chemical system. the pressure that we are going to use, is it higher? No, it's not higher, since in the problem it was given to be 1. But let's select no. And if it is no, then it will tell you that no. If it is no, then the thermodynamic model that you can use is NRTL. NRTL, you can use NRTL to move. So if what you were saying, you need a different thing and you click on this, it will send you to this part. I want to show you something. Okay, so this is a different property method which is called Wilson. So in this Wilson, all these formulas has been embedded in Wilson, and from this reference book. Yes. So once you command Aspen Plus with good or correct specification, it is going to quickly use these formulas to solve what you need for you. Is that not nice? So now we are going to use NRTL. So always you can come here and select all. Then you come to NRTL. So you can just click on the drop down and look for NRTL. NRTL. All right. So we have NRTL here. We select NRTL and you see that it has tick blue. The sky is blue. You can run, or you can run since it is ready, or you go to next, then to tell you run the property, or you run property. You are running property. Okay, so now you are seeing warnings because there is no binary interaction between the components when we use NRTL. So when it happens like this, Aspen have a way that you can use to predict the binary interaction between the two components that you have selected. So all that you have to do is to go to method and locate parameters. Go locate parameters, and in parameters go to binary interaction, and at binary interaction section look for the property method that you are using, NRTL-1. Okay, but when you come here you can see that the components, there is nothing here, and you can estimate it using Aspen powerful tool that's called Unifac. So we go to you check in estimate using Unifac, then you run. Okay, so when you run it, Aspen has given you it has provided it for you, and now you can see that the results is available. There is no warning for here again because now that we have estimated it. So the estimation, it uses the chemical formula structure to predict the binary interaction between the two or more chemical components you have inputted. So now that we have known how to do chemical components, like we have known how we can input chemical components, let's switch to the simulation environment. We are pressed with time so that we can do our simulation. So okay, so now this is our simulation environment. So you can see in the model palette we have mixers, separators, exchangers, columns, reactors, pressure changers, manipulators, solids, separators, batch models, and others. So we are going to go through all these by the end of the bootcamp, and you will be abreast in using it, and you combine them to do a project. Okay, so now let's start. In order to draw a flow sheet, a flow sheet has streams, block, and blocks. So you have input stream and outlet streams. So now click on the stream. In order to bring the stream to the main flow sheet, you select what you need. So when you select it like this and you bring it to the main flow sheet, the cursor will change. Mind you, the cursor was this. Now, when we select it, will change to an insert mode. So you just click anywhere, then you bring it to where anywhere that you need. So you just click there, then you give it a name. I'll say the name of it. This will be the first one, so I'll call it base. Yes. Then I'm going to bring what I need because it is a mixing that we are doing. We need something like a beaker. So I'll bring a tank and I'll put the tank here. Yes, and I'll name it beaker. Okay. So now that I've named it beaker, how if I select any other part, it's going to continue to repeatedly provide a lot of tanks for me. So how do we cancel the insertion mode? You can bring the cursor back to this arrow and you cancel it, cancel insert mode. Or if it still persists like this, you right click to cancel the insert mode. And the last one is you use escape to cancel it. That's clear. Now, how do we delete this since we don't need it? So highlight it. So click anywhere, click and hold and highlight. So once you highlight it, you hit on the delete button and you delete it. Hope that's okay. All right. So now let us enlarge our beaker a bit. So you just select it, then you bring the arrow to where we have the red and black dots, and you see that the cursor will change. So we enlarge it. Okay, we have a beaker here. I'll put the name. Remember, this naming contains it can only take up to 8 characters. So I'll just bring it here. Yes. Okay, bring it here. Now we are supposed to join this stream to the model. So how do we do that? You select the base model, right click on it, go to reconnect. Because we are sending it into a beaker, that will be our destination. Just click on that. Okay, so now that is done, we need an outlet stream. So out, then so remember when I was connecting, there was red. So you are supposed to always connect the red ones first. That's the required input. Without it, you can't do. This one is an optional. So red means it is required. So just click on the required and you draw it out. So this will be our solution and our AQL solution. Our AQL solution. Now we are supposed to add the water that we are going to use to do the dilution to it. So we just click on the water and you draw it back. So this is water. Okay, now insert to cancel. Yes. Now we are supposed to specify the properties. So when we come to our problem said the chemical components, all of them are 25 degrees Celsius and 1 atm, and there's no pressure drop in the mixer. So, and also the flow rate of the base is 500 kilogram and that of water is 350. So you go to next. The next will take you to the base material that we used. So now we said the temperature is 25 degrees Celsius and the pressure is 1 atm. So you type 1 there, then you look for the correct unit, that's atm. Now we have total flow basis. So because our flow basis is in mass, we have to change it to mass. Then the total flow rate that was given was 500. Then you come to composition. So we are going to select mole fraction of base, and it's a pure compound, so the mole fraction is going to be 1. Yes. Remember, it is appearing base here because we indicated it in the property method as base, but the actual name is NaOH. Okay. So once you are done with this, you see that it has tick blue. You can go to next as red is attached to water here. It means the water stream is not done. Go to next. Then you just type in that one is also 25 degrees Celsius. Okay. One. Then the ATM, you can choose to search for it or start typing 80. 80. Now ATM has come. Okay. Now it is one way. If you know the flow rate, you can choose to type the flow rate here and specify the mass fraction or mole fraction at the composition session. Or if you just know it, you can just select mole flow and just type water, the amount of water that was stated 350. Okay, and that's understandable. So once this is done, you can see that everywhere it is blue, the sky is blue. We are supposed to run to see if you are not going to get errors in the calculation whilst Aspen is doing it, and review our results. So click on run or go to next, and it will tell you if you want to run it now, and it's true you want to run it. Okay, so we wait as it keep on calculating. Yes, so now see table has been generated. Errors 00. There was some small warning that wasn't stated. Okay, so the results is available. So how do we view our results? How do we view our results? So to view the results, you go to home, come to stream. You can select all. It will give you the stream, all the streams, but in alphabetical order. Or you can just look for boundaries and it will just give you the boundaries. All right, so let's select all and let me show you how you can change it. All right, so we have a base and this is the water and this is the solution. Okay, so how I change it is you just tap on the drop down, you look for what you want it to come. I want to arrange it from the inputs to outputs, so you select on water and this one you select solution. All right, so now you can see that the phase or the phase that we are performing the calculation is liquid phase. No, so NaOH at 25 degrees Celsius, the conventional one, is a solution that we are diluting. Okay, so now you can see that the temperature remains that, the pressure, because there's no pressure drop, is ATM, still 1 So you can change the pressure to any unit that you need. If you want to change it to PSI, you can change it to PSI and you see the 14.69 PSI, 14.7 as you all know PSI is 1 ATM. You can change it to Pascal, 101325 Pascal, so 1 ATM and everything. So Aspen can be used even for you to be doing change of units, and you move and you can see that the vapor fraction in this is 00 and liquid fraction is 1. Okay, so now that we have been able to get to this session, let's try to view the mole fraction of base in the solution. So now you can see that, okay, this is the results. We have this is the solution and the composition. We have 60%, 60% solution, 60% of water in the aqueous solution, and we have close to 40%, 40% base. Okay, so people, this is our problem, and when we are done with this, and you can see that using 350 to dilute 500 NaOH, you are going to get the mole purity. or the mole composition of the base in the solution to be 40%. You can try this manually to check and try this manually to verify it. So using your CPC knowledge, you can try this to verify what Aspen has been provided to us. Aspen has been provided to us. So you can see that we have the flow, the mass flow rate here. So this is our mass balance as you have learned it this in second year and we in final year, third years, we have already learned it. So this is our mass balance. So this is the mass balance that we have done. Okay, and we have the energy balance as well here. That will be learned by the second year, and God willing next semester. So joule per second. So you can see what we have done. The negative symbol is there for you to show it is exothermic or endothermic. Okay. So liquid flow is also here. So we can change the units. So let me change it to cubic meter per hour, and this is our answer. Yes, the volumetric flow rate. This is our volumetric flow rate. This is our volumetric flow rate. Yeah. Yes. So people, this is where we are going to bring this first session to an end. But let me add, if you want to see the results here, you can go to modify and click on the mass flow rate. The mass flow rate is going to provide at a glance a simple mass balance that you can see. So 350 plus 500 giving you 850. So mass flow rate. You can check in the mole flow and it will do that for you. You can check in the pressure. Pressure is the same. You can check in the temperature. Temperature is the same. Okay. Volumetric flow. Volumetric flow in liter per minute. Okay. So that's that. So we'll end today's section here, and as the assignment says, what will be the mass flow rate of water to produce 20% of NaOH in the solution? It will be collected. I will inform you when I will take it. So try and do it yourself. Okay. So before we end, let me show you how you set up Aspen. So now the work that we did, we can give a title to it here. So I will give a title to it as bootcamp -1, and you can give a description, and the description will be the problem. So I'm just going to go to my this side and copy everything. Yeah, Control C, come to this session, and I'll just paste. All right, and it will be done. So anybody that will just take my file, I send my file for review or something, I'll just go to description, I look at anything. So you can sometimes type a problem that you are facing in this session. Maybe, can you help me? Can you help me to do the assignment 1? So this will be sent. So as soon as I open it, I go to description. So as we are learning from beginners to intermediate or expert level, let's try to make use of the description and the title column so that anybody that picks it will just know. As we are here, let me try to explain. So Aspen have two modes. So the mode now is a steady state model. It's not changing with time, and you can set it to dynamic and it will change the interface, and that's a topic for another day. And the stream class, we are using conventional. It will be talked about if we got solids, and the flow basis is moles, so we can change it to mass and it will not be anything, it will not change it. Okay, so the ambient pressure, so we can state our ambient pressure. Yes, we are in Ghana, maybe our ambient pressure is 1, we can change it and work it out, but 1 bar is our ambient pressure. And the valid phases, no phase was taken, so if you left the space blank, Aspen will choose its default phase for you. So if you leave it blank, Aspen will choose vapor and liquid. But if you can select any of these, then remove. So vapor and liquid, so we are not supposed to take it. And free water, if there is any dirty water within your uh, the simulation that you are going to do, that one too, you can check this one. And when you come to the simulation window, this section, which is called free water or dirty water, you are supposed to add a stream to it so that dirty water will come. But that will be a topic for another day. That will be a topic for another day. So, okay, in the setup, that's all. And operating year, operating year. So, people, this is our work. We meet tomorrow to continue with our simulation. I hope this helped you and now you understand. Okay, yes. Let me show how we can save our file. So just click on file, go to new. Oh, sorry. We are saving. So you go to save. Then you can save Aspen in about 4 ways. So you can save it as a compound file, which I will open and I'll be able to do simulation on it and submit it to you for you to do simulation and submit it back. Or I can save it as a PD a document that I can only view it, but I can't do anything within it. And I can save it as a backup. So at the example session, all of them were saved as a backup file. So you can take backup, edit it, resave it at APWZ and reuse it. And I can save it as a template that people can be used for that stuff. But because this is our first work, let's save it as a compound file and give it a name, the bootcamp day one. So choose a folder, create a folder and save all of them in. I have Aspen class here, so I will save it here. I'll just put it here. Okay, all right. Okay, I'll just put it here and so that I can revisit it anytime. Okay, so you save it. So once it is saved, you will see that the title bar will change. It will change to Bootcamp Day 1. Okay. So thank you very much for today. If you have questions, direct it to the WhatsApp page and you'll be answered. Thank you. Thank God. Amen. Bye bye.